According to the National Electrical Code, specifically Section 310.15b7, the neutral conductor in certain situations can indeed be smaller than the ungrounded conductors, but there are limitations. The code states that the neutral conductor shall be not more than 2 American wire gauge, or AUG, sizes smaller than the ungrounded conductor or conductors. This rule applies to specific types of installations, primarily residential services and feeders. It is important to understand the conditions under which this reduction in neutral conductor size is permitted. Firstly, the reduced neutral size applies to single-phase dwelling services and feeders. Secondly, it applies to 3-wire services and feeders. Let's delve into the specifics of 310.15b7. This section addresses the sizing of the neutral conductor for dwelling unit services and feeders. The allowance for reduced neutral size is based on the understanding that in many residential loads, the neutral conductor does not carry the same amount of current as the ungrounded conductors. This is due to several factors, including the prevalence of nonlinear loads. Nonlinear loads, such as electronic devices and appliances with switching power supplies, generate harmonic currents. These harmonic currents can cause the neutral conductor to carry a significant amount of current, potentially exceeding the current carried by the phase conductors in some cases. However, the code recognizes that in typical residential installations, the harmonic content is often not high enough to warrant a full-size neutral conductor. Therefore, the code allows for a reduction in neutral size under certain conditions. It is crucial to consider the specific requirements and limitations outlined in NEC 310.15b7 to ensure compliance and safety. If the calculated neutral load exceeds the ampacity of the reduced size neutral conductor, you must install a larger neutral conductor. This is to prevent the conductor from overheating and potentially causing a fire hazard. The phrase "not more than 2 American wire gauge sizes smaller" means exactly that. For example, if the ungrounded conductors are size 1/0 AWG copper, the neutral conductor can be no smaller than 3 AWG copper. If the ungrounded conductors are 4 AWG copper, the neutral can be no smaller than 6 AWG copper. Similarly, if the ungrounded conductors are 2/0 AWG aluminum, the neutral can be no smaller than 4 AWG aluminum. The specific application and load calculation dictate the appropriate conductor size. The code makes specific exceptions for situations where the neutral conductor is expected to carry a substantial amount of current. This is to prevent overloading the neutral conductor and potentially creating a fire hazard. Understanding the application of 310.15b7 requires careful consideration of the anticipated load on the neutral conductor. It is imperative to accurately calculate the neutral load to ensure that the reduced size neutral conductor is adequate for the application. It is also important to note that the code provides guidelines for calculating the neutral load. These guidelines take into account factors such as the type of load served, the presence of nonlinear loads, and the potential for unbalanced loads. By following these guidelines, electricians can determine the appropriate size for the neutral conductor and ensure that it is capable of safely carrying the anticipated current. One should consult the applicable tables and sections of the NEC to determine the allowable ampacities for different conductor sizes and insulation types. These tables provide valuable information for selecting the appropriate conductors for a given application. Remember to always refer to the latest edition of the National Electrical Code and consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and regulations. The NEC is a comprehensive document that is updated regularly to reflect changes in technology and best practices. Therefore, it is essential to stay informed about the latest requirements and interpretations of the code. In addition to 310.15b7, other sections of the NEC may also be relevant to the sizing of neutral conductors. These sections address issues such as voltage drop, conductor dirting, and the use of different types of conductors. By considering all of these factors, electricians can ensure that the electrical system is safe, reliable, and compliant with all applicable codes and regulations. The NEC provides detailed requirements for conductor ampacity based on insulation type, temperature rating, and installation conditions. Conductors installed in raceways or cable trays may have different ampacity ratings than conductors installed in free air. Therefore, it is important to consult the appropriate tables in the NEC to determine the correct ampacity for the specific installation. Furthermore, the NEC requires that conductors be protected against overcurrent by fuses or circuit breakers. The size of the overcurrent protection device must be coordinated with the ampacity of the conductors to prevent overloading and potential fire hazards. It is crucial to follow the NEC guidelines for overcurrent protection to ensure the safety and reliability of the electrical system. In summary, while the NEC allows for a reduced neutral conductor size under specific conditions as outlined in 310.15b7, it is essential to carefully evaluate the application, calculate the anticipated neutral load, and consult the relevant sections of the NEC to ensure compliance and safety. Remember to prioritize safety and consult with qualified professionals when designing or installing electrical systems. The information provided here is for general educational purposes only and should not be considered a substitute for professional advice. Always consult with a licensed electrician or electrical engineer for specific guidance on your electrical projects.